Hello. Today we're going to be talking about FTC, which is a robotics competition and how our robot works. We are 2020-2021 STEM ambassadors. My name is Karima Gayar. I am a sophomore in high school and I'm from Fayette County, and I'm one of your Northwest Senior Board of Director members.
Hello, my name is Saad Hadliya. I'm 17 years old and I'm a junior from Fayette County, and I'm your Northwest District Representative of the Georgia State Board of Directors. Other than the robot and the STEM aspect of it, we're also going to be teaching you about FIRST as a whole, how the competition works, and how the other aspects of it all work. Let's go into detail about how this game works. So this is our robot, but what does our robot do? So each year, the FTC works like this. Every year there's a new challenge. So that way, children have to innovate and change what they do, so you don't have the same thing over and over again. Last year's challenge involved these big Lego bricks, and this year's challenge involved these rings. But normally an FTC competition would have a 12 by 12 field. But since these are remote events and since they are the time of COVID, this field is set up in our garage, which keep our beautiful background, and only 8 by 12 feet field. And this is made for only one robot versus 4. Normally it'd be, like I said, on a 12 by 12 field, accommodating the space for 4 whole robots. But the way the game is set up is there are a few main aspects. The first main aspect are these rings. These rings have to be shot by this robot from behind this line into that goal, or knocking down those power shots. So here, our robot would be able to launch them into different goals, I missed, and get various points. So if you were to shoot, and all of this is controlled by controllers, by Microsoft controllers to be specific, very much Logitech controllers, very similar to what you would play Xbox or PlayStation on. And that moves the robot by 2 human players, which are usually me and my brother. And based on where you get it is based on how many points you get. Another aspect, in the last 30 seconds, you can also hit down these power shots, which will give you even more points. There's different aspects of the game, including the first 30-second autonomous period, which means that it's not controlled by those controllers, but we'll get to that in a little bit. But for the next 2 minutes, your goal is to basically shoot as many rings as you can, up into the highest goal as you can. And also, for these wobble goals are also a very important aspect of the game. These wobble goals will also be used in the last 30 seconds of the game and in that first 30-second autonomous. But in the last 30 seconds, if these wobble goals are over this white line, and you can pick up the wobble goal, which we'll explain how we do that later, and place it over this 12-inch wall, then you get another certain amount of points. But it'll all make much more sense as we explain the robot and show examples of how it works, and even later on an actual match of a competition. But let me show you how some of these work. So the main aspects of it are the intake. So these rubber wheels will take in these rings, and then these green wheels will end up shooting it across the field. And we're going to get into more detail about that later. Another large aspect is the wobble grabber, which is this little mechanism right here, which moves on 3 axes, which again, we'll get into more detail later. But it can close in on it and lift it up from this aspect. But let's let Karim actually go ahead and explain it more.
So the first system I'm going to be talking about is our intake, which is run by 2 motors and 3 axles with gears on them. So the first set of wheels is, because it is our first intake, it is on a rubber band system, allowing us for the ring to come and then curve up onto our ramp. Then it goes to this motor, which runs it by chain, which goes right here and brings the chain power to over here. All together, it will demonstrate like this. So next it comes to our basket, which holds our rings. We are only legally allowed to hold 3 rings at a time in our game. So once it gets to this point, it comes to our shooter, which is run by this motor under right here. And then it goes to a gear train, which brings it up to this wheel right here, making our shooter run at 4,350 rotations per minute. And then once I turn it on, it operates like this.
Okay.
So our next mechanism that we have right now is our wobble gripper. So how this works, it runs on 2 axes of movement and a gripper. So normally we will drive to our wobble goal, and then we would lower this line of axis of movement. which is run by a servo with gears. So then we would drive at the wobble, and then we will get it into our gripping area, and then we would grip it. Then we go on to our second line of axis of movement, which is right here, run by a motor, which will lift our wobble up. And this is run by a motor with a special gear called worm gears, which make it have a very high gear ratio of 24:1. After this step, we would drop it over the wall as so. And we will show that later in this video. Next, we will talk about our wheels. Saw that?
So now, how does this robot drive around? How do we move around this field? Well, we can move in literally any direction that we want. Side to side, forward, backward, even diagonally if we wanted to. And we can of course turn around like a tank. But how does it do all that? The magic is in the wheels. So these aren't normal wheels like you would see on your car, or even a lot of like robots or something. Usually they're normal wheels, like just rubber wheels. But they have these little rollers. And these rollers are angled in a way so that whenever we move these two in the same direction and these two in the same direction, they push in on themselves, basically giving it nowhere else to go but sideways. So here, move sideways, left, right, forward, backwards, whatever we want. And it's all controlled by this little joystick. Whichever way I point the joystick is whatever way the robot goes. But how are these motors run? How are these wheels run? Basically, the way we have it set up is a very efficient system of, we have motors on the inside of our robot. And these are transferred by power through mitter gears or bevel gears. And they allow for transfer of power from one direction to another, allowing us all super compact and super fast, because these motors run at about 300 RPM and they are transferred 1-to-1, giving us almost 300 rotations per minute whenever we drive around. But this driving is super efficient in other aspects too. So I just got me some rings. I just toss them around. I can now go ahead and pick up my controller and take them in. And then whenever I'm with my brother, he can go ahead and shoot them out just like you saw in the earlier clip. But now we're going to go into our next thing, which is those first 30 seconds of the game that I talked about, which is autonomous. Here's a clip of our autonomous.
So this is our robot. Here we start on that line and we go forward. All of this is autonomously. So what we do, since we can't hit that ring that's standing there, we go around it and we shoot the 3 rings that are preloaded into our robot. Before all of this, we even scanned that there was only 1 ring there. Knowing that, we will go back and grab that singular ring, we shoot it, we miss, that happens sometimes, but we now know that it's located in that middle square. We drop it right in there, and then we back up and get points for parking on the line.
So, that was really impressive, and that was something that is all programmed through programming on the computer, which is similar to Scratch, or blocks programming is what we call it. But let me show you something else that you may not have realized. So our robot has to start on one of these 2 lines. And based on where we start is where our camera will point, because we have to detect the rings that are located right here. So, most of the time we will end up starting here. And basically our camera can rotate on a servo to detect which, based on where we are. So if I knew that we were here, and I picked out the autonomous that I would need for here, no matter where the servo is pointing, whenever I initiate the programming, it'll always turn on and point towards that ring. And it'll actually detect how many rings are there. And then it runs through the system as if we were driving it. It picks up the rings, it shoots them up there, it does all of that, but it doesn't have the risk, it has much more of a risk factor. Since we can't stop it, we can't really do anything on our controllers, we're not controlling it. But we do as much as we can to make sure that it's as efficient as it can be. The camera is one of those small things. Another thing is something called encoders, which just keeps things a little more consistent located on the robot. And that's also used in the teleop whenever we're driving. It keeps the motor speed at more consistent powers whenever we shoot. So that way it doesn't vary largely. But I hope you understand a little bit about how that works. So now you get to see a full match of our...
As you can see, we have just finished our autonomous period for this round, and we're right away going for the wobble goal, so we can grab it and put it over the line for the endgame period wherever we can get more points. As you can see, we just dropped it and we start intaking right away. As you can see, our robot is quite fast, and because of our special wheels, which are mechanisms, we can operate very quickly and very efficiently. And as you can see right now, we are shooting. But as you might notice, we already missed one. Well, missing is a normal thing for our robot because sometimes there's inconsistencies and sometimes we have to just work around this and continue going. As you can see, we just continue shooting and we keep trying to fill it in this whole 1 minute and 30-second period. As you can see, it takes a lot of adjustments for our shooting. A little left, a little right, and little adjustments can do a lot for our shooting if we miss or we get into the goal. As you can see, we continue getting in, and I think we get 5 full baskets of rings. And each shot up there is 6 points each. As you can see, we're in the last 30-second period, wherever we try to grab these wobble goals and place them over the wall, which will make us get 20 points each. So you can see we just dropped the first one and right away go for the second one. And we get the second one over the wall as well. And right away, we try to shoot down our power shots, which are 15 points each. But as you can see, sometimes it's not as efficient as we would like, and we miss 2 out of the 3 shots.
So let's do a little Q&A. Since unfortunately we can't be with you and actually present this, we're just going to do some commonly asked questions. So, Kareem, I'm a 5-year-old and I'm wondering, how much does this hunk of junk cost?
Well, we as a team, we spend about $2,000 a year, including
$2,000?
yes, on parts and registration and everything that we need to pay for. But honestly, this robot's quite priceless with all the time that we put into it.
Wow, that was my next question. How much time do you put into this? Like half an hour, like a Lego set kind of thing? 2 hours if it's a complex one?
Yeah, no, I personally spent, as the builder of the team, with trial and error, over 85 hours of just
What?
Lego.
Only thing I've put 85 hours into is like Fortnite.
Well, I really like building robots.
So do you have any rare skins for it? Travis Scott?
No.
Aw, man.
Well, how do you start an FTC team?
Well, if you wanted to start your own FTC team, it's not quite as easy as playing Fortnite, I can tell you that much. It takes a certain amount of people. Our team is currently 6 people. And our team does various jobs. But you have to be able to register with Georgia first, or whatever state you're in. You have to then be able to get the parts that you would need to build a robot. And there's many different brands of parts. We use GoBuilder, there's lots of different brands, but we found GoBuilder to be the best for us personally. And you have to find commitment. As he said, a lot of time goes into this, so you have to make sure that you have committed people.
Well, I heard that FTC is more than just building robots. What do you mean by that?
Well, other than building, programming, and, well, outreaching. What's outreaching? Well, that's what I'm doing to you right now. I'm talking to you about this robot, and that's what we do across our city and even state. I've gone personally, I'm from Fayette County, but I've gone all the way over to Covington to show our robot to their local 4-H agency. I have gone to 3 different local libraries, and we've shown our robot at our 4-H office many times. From little 2, 3-year-olds driving this thing to older women that sometimes crash it. But no matter what, it's still always an enjoyable time, and we always try and do whatever we can, even through these tough times.
Well, thank you.
But wait, isn't there like anything cool that you do? Like, if it's a sport, do y'all have like football jackets or like Speedos, like a swimmer?
No, but we kind of do. Well, we have varsity
What?
jackets.
When did you get that on?
I don't know, maybe I had it on the whole time, you just never noticed. Well, these varsity jackets are MWR.
No, I don't care. I want one. I got one!
Yep, now you're a officially part of our team.
I'm like a giddy little girl whose mama got McDonald's to school for lunch. Oh! Wait, so we have letters on here?
Yeah, we have MWR for Monkey
McDonald's Ratchet Robotics.
No, it stands for Monkey Wrench Robotics.
Oh, that's also pretty. Yo, wait a minute. No, I remember. Didn't we like make it to the world competition last year?
Yeah, but it kind of got canceled because of Corona.
Ah, okay. But aren't you like second best in the state right now and like 27th in the world?
Yeah, that kind of sounds familiar.
Yo, we're pretty cool. But well, I hope that y'all enjoyed our little presentation. You know, a little bit of our comedy.
Yeah.
I guess we're comedians because those were pretty bad jokes.
Yeah, they kind of were. Because we're kind of robo-nerds.
What can I say? But I do hope that you genuinely learned something. I hope that you enjoy Fall Forum. And sincerely from your state board member
And your Northwest board member.
you have a great holiday season. Thank you.
Thank you.
So this is a little editor's note. I hope you learned a lot and I hope that you enjoyed it. And it was a little bit more fun than some of the other presentations. If you have any questions about it, please feel free to contact us either at our robotics Instagram at monkey.wrench.robotics or my personal Instagram at salah_flip_4h or Kareem's personal Instagram at Kareem_El_4h. I hope you enjoyed Fall Forum and I hope you enjoyed this presentation and have a great holiday. Thank you.